So let's have the discussion of the Kruskal Wallis test. Okay. So the Kruskal Wallis test is the non-parametric alternative to the one-way ANOVA. Non-parametric means that the test doesn't assume your data comes from a particular distribution. The H test, or also known as the Kruskal Wallis test, is used when the assumption for ANOVA aren't met, so like the assumption of normality. It is sometimes called one-way ANOVA on ranks, as the ranks of the data values are used to test rather than the actual data points. So the Kruskal-Wallis test is one of the non-parametric tests that is used as generalized form of the Mann-Whittier test. It is used to test the null hypothesis, which states that uh, k number of samples has been drawn from the same population or the identical population with the same or identical median. So the test determines whether the medians of two or more groups are different. So, like most statistical tests, you calculate the test statistics and compare it to a distribution cutoff points. Okay, so these are the hypotheses. Okay, in the Kruskal-Wallis, the null hypothesis is population medians are equal, and then the alternative would be the population medians are not equal. So the Kruskal-Wallis test will tell you if there is a significant difference between groups. However, it won't tell you which groups are different. So for that, we are going to have a post hoc analysis or post hoc test. So examples of the Kruskal Wallis, okay, where we can apply the Kruskal Wallis to certain problems is that, um, for example, you want to find how much or how test anxiety affects actual test scores. The independent variable test anxiety, let's say, has three levels. Let's say you have no anxiety, low, medium anxiety, and high anxiety. So you have three. The independent variable is the exam score rated from 0 to 100%. That's one example where we can apply the Kruskal-Wallis test. Okay, so these are the assumptions of the Kruskal-Wallis. The first one, the group independent variable, one independent variable rather with two or more levels. So it could be independent groups. Okay, the test is more commonly used when you have three or more levels because if you have two levels, it is better that you are going to consider using the Mann-Whittier test. Another is ordinal scale, ratio scale, or interval scale dependent variables. Then you have your observation should be independent. In other words, there should be no relationship between the members in each group or between group. So it is assumed that the distribution should not be necessarily normal, and the variances should not be necessarily equal. So all groups should have the same shape distribution. So most software will test for this condition as part of the test. And lastly, it is assumed that the observation must be drawn from the population by the process of random sampling. Okay, another is you have this one. Uh, so let's have this example. Okay, the guidance counselor of the school wants to determine if the physical activities can alleviate the depression of her students. She allocates depressed students to three groups randomly, no exercise, 20 minutes of jogging per day, and 60 minutes of jogging per day. At the end of the month, she let them rate their feelings from 1 to 100, where the lowest is totally miserable and the highest is statically happy. At 5% level of significance, or the results differ from one another. And you have now the table. So in the right side, you have the table in which every students, and each groups has their recorded uh, levels. Okay, levels of their ratings of their feelings. Okay, so let's move to the Excel. So this is the data, okay, for the computation or the manipulation of the megastat. So for the Kruskal Wallis, we have here, what we're going to do is we're just going to go to add-ins, megastat, and then non-parametric test, then look for the Kruskal Wallis test. So in this case, you could have, you have just, so what we are going to do here is that after you open the prompt, okay, you're just going to highlight the data, and then you are going to check the correct for ties, because as what we had seen in the presentation, the Kruskal Wallis involves rankings. Okay, so we go to okay, and then if you can see, okay, okay, so here, as you can see here, our degrees of freedom is 2 because we have 3 groups. So you have 3 minus 1, that's equal to 2. And then for the H value here, which is corrected for ties, that's equal to 7.290. But what we are going to look for is the p-value. Here in the p-value, okay, as you can see, it's highlighted with yellow, flash yellow. So this means that our p-value is less than 0.05. So as you can also see also in the value of our p, it's 0.0261, which is technically less than 0.05. So this means that we are going to reject our null hypothesis. Okay, let's try to go back to our PowerPoint. So in this case, so our null hypothesis here, okay, you have the medians of the results are equal. And then for our alternative hypothesis, the medians of the results are not equal. As we can see in our results in our megastat, okay, the H is equal to 7.27 with a p-value, okay, of uh, 0.02, which is less than 0.05 as indicated in our level of significance. This case, we are going to reject the null hypothesis. So since we reject the null hypothesis, uh, we could say that the result of the medians, okay, the medians of the results are not equal in this case. So the Kruskal Wallis test revealed that there was a significant effect of the exercise on depression. Take note that you have the jogging, you have the jogging here is the form of exercise to alleviate the depression in this case. So inspection the group means suggests that compare if we go back to our Excel. So here, if we are going to get the uh, visual inspection of the groups, we could see here that compared to the no exercise, which could be considered as our control condition, depression was significantly reduced by 60 minutes of the total exercise, but not by 20 minutes of exercise. So the Kruskal Wallis test has one limitation. If the researcher does not find a significant difference in his data or in the data of the researcher while conducting it, then the researcher cannot say that the samples are this same.